The museum's collections are over 150 years old. Some of our specimens are as ancient as the planet itself, while others were recently collected. We're looking at young and old. We'll explore different life stages, as well as some of our newest and oldest specimens. Let's check in with the museum experts to discover some of our natural history treasures.
Though it doesn't look it, this is no ordinary rock. It's a piece of the Acasta Gneiss complex in the Northwest Territories of Canada. It's widely accepted to be the oldest rock on Earth, dating back to about 4.03 billion years old. So, how do we know it's that old? Scientists look for specific minerals called zircons, and when zircons crystallize, they trap a certain amount of uranium in their structure. Over time, the uranium decays to lead, so what we do is we measure the amount of uranium, compare it to the amount of lead, and we can calculate the age of the rock from that. Tectonic cycling of the Earth is continuously subducting oceanic and crustal material into the mantle, remelting it and making new rocks. So it's quite rare to find a rock that, for 4 billion years, has managed to escape that process.
Here we have some very young copper specimens. They were formed in the last several decades as the result of human activity on the walls of Britannia mine in BC or on the old pipes.
This is one of the most recent specimens that we have in the manual collection of the Canadian Museum of Nature. And this is a wolf with the complete skeleton, not even a tiny bone missing. We have also the skin that we have taxidermied, and we have taken a fresh tissue that we are preserving in the cryobank of the Canadian Museum of Nature. We have the whole sequence of the DNA. And this is our oldest specimen here in the mammalogy collection. It's a cougar that has been taken in Trois-Rivières in 1828.
From eggs to adults, birds go through a number of changes throughout their life. Features such as plumage, eye color, foot color, beak color can all change throughout their life. Take, for example, the bald eagle. When they're young, they're actually so different that they can be confused with another species, the golden eagle. So they start off almost entirely brown. So from head to tail, everything is dark. And throughout the years, they gradually change, going from one plumage to another. And finally, fifth year, becoming the adult bird that we all know.
So we have some fossils here representing young and old animals. And these two bones here represent a steppe bison. So these are about 50,000 years old. And here we have a very good example of a bone from an older individual. You can see that it's much larger than the younger one, but it also shows all of this irregular texture, and that's all evidence of arthritis. Whereas in the younger animal, much smaller in size, very smooth, and you can see at this end that it's missing this rounded cap, and that cap actually fuses with age, so that the lack of the cap is also an indication that this is a much younger animal.
On first glance, you might not think that fish that look as different as this tarpon or this bonefish, which can grow to over 2 meters in length and are very popular sport fish, are closely related to eels, such as this fabulous spotted moray. But if you follow them from egg to adult, you'll see that they share this incredible larval stage called the leptocephalus, which means thin head. Now this leptocephalus larvae looks so different from the adult that it was originally described as a new species. So now you know why these very different fish are closely related, but you can also determine whether something that looks like an eel is actually an eel. If it doesn't have the leptocephalus larvae, it's not a true eel. Sorry, electric eel.
Here at the National Herbarium of Canada, we have specimens that were collected over 250 years ago, as well as specimens that were collected as recently as this summer. This is one of our oldest specimens, a bunchberry collected from Newfoundland by Sir Joseph Banks in 1766. And here is another specimen of bunchberry from Newfoundland, but this one was collected in 2016 by members of museum staff. Despite the quarter millennium age gap, these two specimens were actually collected very much the same way, by pressing the fresh plant material between two slats of wood or cardboard and binding them together to dry in what we call a plant press. Comparing specimens that were collected in the more distant past with more recent specimens can reveal new information about plant form, function, and diversity.
With its active research and collection division, Canada's Natural History Collection will continue to grow for many years to come, helping scientists from around the world better understand life on our planet.